This video, part of the Airport Design Technical Video Series, provides guidance on designing high-speed exit taxiways by the Office of Airports at the Federal Aviation Administration. For information on high-speed exit taxiway design, refer to Advisory Circular 150/5300-13, Airport Design, for specific design standards. See www.faa.gov. Images in this video are graphical representations only and are not to scale. Discussion topics include an introduction to high-speed exits, high-speed exit without or with a reverse turn, and planning and design considerations. Introduction to high-speed exits. High-speed exit taxiways reduce runway occupancy time and may increase runway capacity if optimally located. This is especially important at busy hub airports during peak period operations. As shown, landing aircraft require more distance and time to slow down to taxi speed prior to exiting a 90-degree exit. Optimization of high-speed exit locations allows aircraft to exit the runway at a greater speed and shorter distance. This reduced runway occupancy time may increase aircraft arrival rates and runway capacity. The reduction in arrival runway occupancy time allows a waiting departure aircraft to use the runway more quickly. When planning for runways or parallel taxiways, analyze the types and locations of runway exits to optimize the exit locations and to minimize runway occupancy time. The Runway Exit Design Interactive Model, REDM, is the FAA's preferred method for analysis. This model can be found at the link shown. The REDM model uses specific runway data, aircraft fleet mix, and aircraft performance characteristics to optimize the location of high-speed exits. For example, 3 possible runway exit locations for a high-speed exit demonstrate the average runway occupancy time achieved at each location, according to REDM predictions. The preferred exit location achieves an average runway occupancy time of less than 50 seconds. There are 2 configurations of high-speed exits. The first configuration does not have a reverse turn, as the airplane continues directly onto the parallel taxiway in the same direction. No additional pavement is needed for the inside fillet. The second configuration has a reverse turn with a larger inside fillet for the airplane to reverse direction onto the parallel taxiway. The inclusion of a reverse turn may diminish the benefit of a high-speed exit, given a pilot will need to quickly reduce speed to execute a reverse direction turn. Design high-speed exit taxiways for exiting the runway. They are not appropriate for use as entrance taxiways. Using the high-speed exit taxiway to enter the runway creates a diminished pilot viewing range, thus increasing runway incursion risk. The design of a standard high-speed exit without a reverse turn includes the following design parameters: a 30-degree angled high-speed exit, a turn radius of 1,500 feet for the runway exit, a fillet radius of 25 feet for the fillet at the parallel taxiway. For a standard high-speed exit with a reverse turn, design parameters include the same 30-degree exit and 1,500-foot exit radius. Increase the inside fillet to allow for adequate pavement width for the reverse turn. Base the design of reverse turn fillets on the Taxiway Design Group, or TDG, of the critical aircraft and the runway to taxiway separation distance. The Acute Angle Exit tool on the FAA's website is the preferred method for designing standard high-speed exits. Case A is where delta 1 and the exit angle are the same. Case B is where they are different, which is when delta 1 is determined by the minimum radius of turn radius 2. Users input specific design parameters including TDG, in this case TDG 6, runway to taxiway separation distance, exit radius, and exit angle. The tool calculates the design dimensions for each of the reverse turn fillet dimensions and the high-speed exit's overall geometric design. The following are important planning and design considerations for high-speed exit taxiways. To improve pilot recognition of a high-speed exit taxiway, install taxiway centerline lights. This is particularly helpful at airports that experience frequent low visibility conditions. Do not co-locate two high-speed exit taxiways. This results in a wide expanse of pavement along the runway and does not allow for standard location of surface navigational aids, including airfield signs, markings, and lighting. Provide adequate separation distance between opposite direction high-speed exit taxiways to provide for standard placements of surface navigational aids and to enhance pilot situational awareness for exiting the runway. Do not co-locate a high-speed exit with a crossing taxiway, as this complicates surface navigational aids at the runway taxiway intersection and may affect the pilot situational awareness due to multiple paths and a wide expanse of pavement at the exit location. Best practices include providing separate high-speed and 90-degree exits along the runway. When planning new runways and/or new parallel taxiways, provide at least the minimum standard runway to taxiway separation. Base the minimum separation distance on multiple variables including critical aircraft, airplane design group, taxiway design group, aircraft approach category, airport elevation, and future use by larger aircraft. See AC 150/5300-13 for further guidance. Do not design high-speed exits that lead directly to another runway, or directly to an outer parallel taxiway, or aircraft parking apron. A high-speed exit between parallel runways increases runway incursion risk due to the two adjacent hold lines between the runways. Best practices include taxiway geometry that directs the pilot to first exit onto a parallel taxiway and then make at least one turn before crossing a runway, a parallel taxiway, or an aircraft parking apron. These reference materials provide additional guidance on high-speed exit taxiways. Visit www.faa.gov to find related documents, videos, and airport design tools. For additional information on high-speed exit taxiways, contact the FAA's Office of Airports. The FAA appreciates your interest. Safe flying!